All right, welcome to 5.3 and 5.4 video. This one's probably going to be longer probably than 5.1 and 5.2 because there's a lot of patterns in here and you got to pay close attention. So you might be re-watching some of these examples. In 5.3, we're going to factor trinomials now in the form of ax squared. There's no longer going to be a 1 here in front of our x squared. All right, so we're going to have to use that ABC method I told you back in the last video in 5.2 how to factor. It's still the FOIL process backwards. Everything you see here between these two binomials, all your rules are the same. The C, if it's a positive, signs are the same. If it's a plus, the two are plus. If it's a minus, the two are a minus. If my 10 is a minus, my signs are opposite. Okay, notice though, this time, I'm not going to step on a limb and say, oh, here's my minus 11. This is going to be a big number. It's going to be negative. It might not be, because if this is where the big number comes from, it's going to depend on who's being multiplied to that 2 or the 5 that makes this bigger. So we're just going to take the fact that if it's a minus 10, it has to be a plus and a minus. All right? Now, same thing happens. F times the L, 6x squared times 10, 60x squared, 15x times 4. Same rule applies here, so this is going to be my ABC rule for factoring. What two things multiply to be A and C, which are these two products, and that has to be what two numbers add up to be that same value. Okay, so we're going to keep that in mind. The same two numbers multiply to be a 60. The same two numbers have to add up to be your 19 or your 11 here. Now, some authors or books, I'm not going to cut around the chase here, are stupid. This is actually in a book. They said factor 3x squared minus 10x minus 8. And they said, you're going to do trial and error. What? Guess and check? They say, well, look, the two factors of your 3x squared has to be 3x and an x. So we're going to build a bunch of binomials that start with 3x and one with an x, and I'll say, what's all the factors of a minus 8? Negative 1 and 8, 1 and minus 8, 8, negative 1, negative 8, 1, 4, negative 2, negative 4, 2, negative 2, 4, 2, negative 4. All the possibilities with your signs. We're going to put those all in the parentheses, and we're going to FOIL them out. And they say, well, it's not that hard because all you should really do is multiply the 3x times the 8, the negative 1 times x. You should just do the outside and the inside and combine those together and see if you get your minus 10x. Well, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 multiplications I had to do, and I finally got the right combination. Oh, okay, there's my answer. No, we will never guess and check. Huge, huge waste of time. If you want to guess and check, I guarantee you this won't be 3 and a 1. This might be a number like 12. So you got to go 1 and 12, 2 and 6, 3 and 4. And I'll make this number 48 or 49 or 56. I'll make numbers with all kinds of factors and make your life as miserable as possible. Because it's fun. Now, so I've done this so many times that I've finally discovered that all this right here can be condensed down to 3 possibilities. All these trinomials in ax squared plus bx plus c, there's 3 distinct patterns. The first one is the odd rule. The odd rule happens about 55% of the time. And the reason I call it the odd rule is because your middle term is odd. Now remember your number sense here. Number sense says that the only way you can add up 2 numbers to get a 7 or subtract, one has to be an odd, one has to be an even. That's huge. That's going to really assist us in finding our numbers. So nothing's going to change here. Okay, now I can't put x and x in the front of my binomials because this could be 10x and 1x, 2x and 5x. I'm not sure. But I do know it's a minus 12. My signs are going to be different. 1 plus, 1 minus. So we're going to work this out slowly, and then we're going to discover a shortcut. So bear with me. So we need to find out what two numbers, A and C, 10 and negative 12, will add up to be 7. Now, if you multiply this and call it negative 120, and if you want to drive me absolutely crazy, this is where you get even with your instructor. If you want to absolutely drive me insane, because it's technically not mathematically incorrect, what it is mathematically stupid. Some of you may have been taught to do the following. And if your teacher told you this, then they are stupid. Okay, then he said, 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 7 doesn't work, 8, let's see, 8 and 15, 9 does not work, 10 and 12. So as this side gets bigger, this side gets smaller until you meet in the middle, and now you know your whole list is done. Okay, by the time you write this all out, when we're done, you'll have the answer when we're done. Now, the reason I say this is stupid is because we said you had to have an odd and an even to get to the 7. You need an odd and an even. Well, folks, I just found an even and an even, even and even, even and even, even and even. Half of my choices that I went out and found won't work. Why am I wasting my time finding numbers that I now know don't work? So don't do this. No. We're going to work smarter, not harder. All right, here we go. 7 is odd. That means you got to have an odd number and an even number. So what we're going to do with the 10 and the 12 is we don't multiply them together. We break them down. We work with smaller numbers. Your brain works faster with single digits than it does 2 digits and 3 digits. So 10 is 2 and 5, 12 is 3 and 4. I didn't take 6 and 2. Why? I need odd factors. I need an odd factor here, so I want to go with the 3 and the 4. So here's my thought. Now remember, number sense. Odd plus an even. I have 3 times something, a 5 times something, and oh, by the way, remember, an odd times an odd is 15. Okay, so if you cover up the 3, 2 times 5 is 10 times 4 is 40. I cover up the 5. 2 times 3 times 4, that's 24. All right, 5 and 24, nope, that's not going to subtract to get me 7. Cover up the 5 and the 3 for my 15. 2 times 4, that's an 8. 15 minus 8, that's my 7. There's my two numbers, 15 and negative 8. I only had to make 3 possibilities. Remember, on my iPad I made 8. I'm less than half the work. Now I've got my O and my I term. We have to do factor by grouping. So my 10x squared stays the same. Now my plus 7x is really the plus 15x minus the 8x minus the 12. So I cut this in half. Have a plus something here, which means I have to have a plus here. They have to match, remember. So I see a GCF on the left side of a 5x, which gives me a 2x plus a 3. Now this 2x plus 3, remember from factor by grouping, has to be the same as right here. It has to be the same because we made this rule up here work. It has to work. So negative 12 divided by positive 3 is minus 4. 2x plus 3, that must be my plus 1. 5x minus 4, I'm done. I don't know about you, but that's a whole lot quicker and easier than guessing and checking. Now, some people will ask me, well, Mr. Fitz, I got a question. Does the 15x and the minus x have to be in this order? Absolutely not. You could put the minus x first and the 15x second. So if we work that out, cut it in half. Now it's got to be a minus here and a minus there. So I'm going to take out now, let's see, a 2x, and I have 5x minus 4, which means this is 5x minus 4. Negative 12 divided by negative 4 is a positive 3. So I'm going to have 5x minus 4 and 2x plus 3. It doesn't matter which order they're in. I have my answer. Wait a minute. This is going to be kind of weird. I see a pattern here. I see a pattern. I want my answer 2x plus 3 and 5x minus 4. Do you notice that right here? These two terms, I took out the GCF. There's one of my answers. And down here, I take the 10x squared and I matched it up with the minus 8x, took out its GCF. There's my answer. So I'm thinking, what if we just focused our attention on the left-hand side, right here, because I want those answers. So what do I need to do is I need to combine the 10x squared plus 15x, the 10x squared minus 8x, to get to, wait a minute, I don't even have to put the x's there because I'm always going to factor out an x. So I'm going to take this a step further. I need to combine the 10 with the 15 and the 10 with the minus 8. So remember when we talked about how do we set up our answer, we would take this 10, put it in with an x in the front of each binomial. Okay, so the 10x minus blank, that's going to help me build this one. The 10x plus the blank, that's going to be with the plus 15. So this is what my answer looks like. So from now on, what we're going to do is we're going to write this down, do this work, put in your numbers, positive 15 and minus 8. All right, there's my minus 8, there's my positive 15. This is not my answer because I have yet to taken out the GCF of the 5 and the 2. So what's the GCF of my first binomial between 10x minus 8, which is the same as saying 10x squared minus 8x. We just left out the extra x. We take out the 2. That's 5x minus 4. Then I match the 10x plus the 15. That's right here. We take out the GCF of 5. That gives me the 2x plus 3. And this is my factor by grouping shortcut. It works all the time. Now, some of you may have been taught this crazy thing called bottoms up. If you do it, I will mark it 100% wrong because it's wrong. It is false. It's smoke and mirrors. It doesn't work. Nothing about it is mathematically sense. It's all tricks. So let me show you what I'm talking about and why I will not count it. I have seen students take your 10x squared plus 7x minus 12, and they rewrite this by taking the 10 and multiplying it over here and calling it x squared plus 7x minus 120. Okay, these two statements are not equal. You're automatically wrong. That's not mathematically correct. If you don't believe me, let x equal 0. Okay, that's a 0, that's a 0, be negative 12. That's a 0, that's a 0, that's negative 120. They're not the same statement. So do not do this thing called bottoms up. It's mathematically incorrect. You do it in my class, it's 100% wrong. There will be no exceptions. No points given. Okay? All right, let's try another one. Okay, this is the odd rule because the middle term was odd. All right, now there's an even rule. Two even rules. Even plus an even. This is when the middle term is even and your A or the C, one or the other, is an even. This is when an even plus an even. This happens about 30 to 35% of the time. Now, how does this work? Well, we're going to use that new shortcut. It's a minus, 1 plus 1 minus. Use that leading 8 on both of the first terms, and we'll take out our GCF here in a second. So we put up our ABC rule. What two things multiply to be 8 times negative 15? Again, don't multiply them. Add up to be a negative 14. Okay, so let me explain the number sense. Since 14 is even, these two numbers have to be even. Now, true or false? Every even number is divisible by 2. So you have to have an even number up here. There's got to be one. It's my 8. Break that 8 down to all 2's. Break your 15 down to 3 and 5. Now, because these two numbers right here have to be even, I am going to put this red 2 parentheses in each blank. It's an even number. It has to be divisible by 2. So what I'm saying I'm doing is I'm taking this 2 and making it part of this number, this 2 making it part of that number. They're gone. Now, that means negative 14 has to be 2 times a negative 7. So in other words, what's in this parentheses plus what's in this parentheses has to equal negative 7. Wait a minute, that's odd. 3 times something, 5 times something, 15 times something. Cover the 3. 2 times 5 is 10. Oh, how about a negative 10 and a positive 3 is a negative 7? There's my numbers. Positive 3, negative 10, 6, and negative 20. 6 times negative 20 is the same as 8 times negative 15. 6 minus 20 is negative 14. Where do I put the 6? It's positive. It goes in the plus blank. Negative 20. That 20 goes in the minus blank. Now, are you ready? We're almost done. What's the GCF of our first binomial? It's a 2. 8x divided by 2, 6 divided by 2. That's your GCF you take out and factor by grouping. 4x plus 3. 8 and 20, we can take out a 4. Notice that 2 times 4 is 8. That's the extra 8 we put in our parentheses. It's divided out because that's your GCF. 2x minus 5. Go ahead, FOIL it out. You'll get the same answer right there. So when you run into an even plus an even, we want to think about taking out a 2, putting it each blank, and put parentheses there, and what's ever left over after you divide 2 out of the 14 has to make a 7. This case is odd. Now, this could be an even number, which means you're going to have more even numbers up here. Go from there. All right? Now, I have seen students, believe it or not, I've actually learned something from them as well. Okay, and it does work. It's another way of looking at it. All right, so I have my 8x squared minus 14x minus 15. Blank times blank equals 8 times negative 15. Blank plus blank equals negative 14. All right, 2 and 4, 3 and 5. Those are my individual factors. Students have told me that because there's only 3 2's here, eventually that extra 2 has to be multiplied by another 2. That's the 4, which I agree. And they would say, okay, so I take the 2 and match it with a 3, a 4, match it with the 5, or the 2 matched with the 5. Let me write this down. 2 times 3 is 6 and 20, or 2 times 5, 10. 4 times 3, 12. Okay, which one's going to get me to negative 14? Right there. 6 minus 20. There's my 2 numbers. So that's another way to approach it. That is if you get 3 2's when you break this down. If you get 3 2's, go with a 2 and a 4 and whatever your other factors are here. Just another way to look at it. All right, the last rule. is an even rule, but it's made up of an odd and odd. Now, how do I know when it's an odd plus an odd? My middle term is even, but look at A and C. They're both odd. This happens 10 to 15% of the time. Not too often because they're hard to make up. Okay? And I'll be honest with you, they're pretty easy to factor. So I got a plus 63. Signs are the same. They're both minus. So take the first A, the A and the x squared, 3x minus something, 3x minus something. What two numbers multiplied? Be 3 times 63 and add up to be 34. This is going to be difficult because you got to break down the 63 to a bunch of odd factors. 9 and 7, and 9 breaks down to 3 and 3. They're all odd factors. So this looks like it's going to be a lot of work. 3 times something, then a 7 times something, and now I got to multiply 2 3's together, 9 times something, and then I got to multiply a 3 and a 7 together, 21 times something, and then I got to multiply all the 3's together, 27 times something, and then I got to, wait a minute, 3 times 7, that's 63. That goes with my right here, 63. So I don't have to, wait a minute. Watch what's going to happen here. You're gonna like this. 3 times 63 would be the same as 63 times 3. Isolate the 7. 3 times 3 times 3. That's 27. That's this 27 right here. So this is 27 times 7. So this adds up to be my negative 34. There's my two numbers. Just to finish this off, 9 times 21, 21 times 9. So you only really have to create half the numbers. That's why I didn't write 63 times something, because my 63 times 3 was right here. So the smallest and the largest, smallest, it's only going to be half as many factors. So there's my minus 34. Put the minus 7, minus 27 in. It doesn't matter because they're both minus minus. The first binomial has no GCF, so that's part of my answer. This has a GCF of a 3, which gives me x minus 9, and that's my answer. We have it factored. All right, so factored completely. 3x squared minus 10x minus 8. All right. Completely, watch out for that GCF that we may have to find. I don't see a GCF. I see a minus, so it's plus minus with the 3x leading us off. 3x plus something, 3x minus something. Okay, it's an even, and you have an even for the C. So we want to take that 8, like I said, break it down to a 2 and a 4. My 3 is the only odd number, so it's either going to be 3 times 2, 6 and 4, or 12 and 2. Now remember, they're opposite signs. They have to subtract. So I have to have one bigger than 10. 3 times 4 is 12, and the 2. So positive 2 minus 12, that will add up to be the negative 10. 3 times negative 8 is negative 24. 2 times negative 12 is negative 24. So the 2 goes in the plus blank. The 12 goes in the minus blank. No GCF here. GCF of a 3 here. Gives me x minus 4 when I divide 3 from both terms. There's my final answer. Now, this should look familiar to you. Remember that part I told you in the book where they had it foiled out 8 times? All that work, look how quick and easy and least amount of work to get to where we want to be. There is a method to the madness. It always works. 3 forms. Even rule, odd rule, that's all you have. All right, 5x squared plus 7x minus 6. It's a minus, so my signs are going to be different. 1 plus 1 minus, we're going to put a 5 in front of each x. That's what my answer is going to look like. We'll just have to take out the GCF. Probably one of these will be divisible by 5. What two numbers multiply to be 5 times negative 6 and add up to be an odd? It's odd, so break the 6 down. to a 3 and a 2, you have to have one odd, one even. So I'm thinking here is that, well, 5 is isolated. 5 and 6 don't work, so let's isolate the 3. 2 times 5 is 10. 10 and 3, there they are. So a negative 3 and a positive 10. 10 minus 3 is my 7. So since 3 is negative, it'll go in the minus blank. 10 is the positive, goes in the plus blank. Take out the GCF of 5 here. Gives me x plus 2. No GCF there. 5x minus 3. Now again, remember I said one of these will have to be divisible by 5, which means one of these two numbers is divisible by 5. So the 5 had to be multiplied by the 2 or to the 3. Okay, since I needed an odd and an even, I went with the 2 times 5. And there's my answer. Okay, whoops, wait a minute, x cubed, well, timeout. I see even numbers, I see x's, I see a GCF of a 2x. Let's take that out first. I'm left with 4x squared plus 11x minus 3. All right, let's talk about what our answer looks like. It's a minus 3, signs are opposites, put a 4 in front of each binomial. Notice I took the 2x and put it in my answer down here. Okay, so what two numbers multiply to be 4 times negative 3 and add up to be 11? Remember they're opposite signs, so they have to, so wait a minute. 11's big, 4 and 3 are small. That's a 12. It's going to be 12 and 1 are my two numbers. Okay, how did I see that? It says 11 was really big compared to the 4 and 3, so I multiplied it together to get a 12. 12 and 1 are my factors. Negative 1, positive 12. 12 goes in the plus blank. Negative 1 goes in. So right here, we'll take out a GCF of a 4 from the binomial only. Leave the 2x alone. X plus 3 with the 4x minus 1 because there's no GCF. There's my final answer. 15x squared plus 44x plus 21. Gadzooks. Even with odds. Ooh, this is, okay, this could be crazy. So plus plus, we need 15x plus something, 15x plus something. What two numbers multiply to be 15 times 21? And they have to add up to be 44. So here, let's break this apart. 3 times 5, 3 times 7. Now, here, this could be a mess, but because we have repeating factors of 3 in each one, what this is telling me is that it won't be smart to match this 7 up with this other 3. So what I'm thinking is we have to switch the 3 and the 5 around. So let's group 3 times 3 and 5 times 7. 9 and 35 add up to be 44. Ding, 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 there's my two numbers. See, it's easier to break numbers down to small digits and do a little switcheroo here. Multiply them back out, we got our numbers. So 9 and 35, doesn't matter which blank they go in. Here we have a GCF of a 3. That's going to give me 5x plus 3. A GCF of 5, notice 3 times 5, that's the extra 15 we put in. That's going to give me 3x plus 7. And there's my final answer. Next, more factored completely. Here, the author's trying to trick us. 6x squared, notice they put a plus 4y squared minus 19xy. This is not in proper order. The y squared has to come at the end. So we need to rearrange it so we have an x squared at the front, y squared at the back. You could go 4y squared in the front, 6x squared minus in the back. Then you just have y first, x. Doesn't matter. I prefer x's first, y second. So here it's a plus 4, same sign, both minus signs. 6x is going to lead us off. So 6x minus blank y, 6x minus blank y. All right, what two things multiply to be 6 times 4? A and C add up to be a negative. Oh, that's odd. That's odd. There's only one possible odd factor up here. That's out of my 6. That's a 3, so it's got to be by itself. So 3 and 8, wait a minute, 3 and 8 don't add up to be 19. Okay, so maybe it's 24 and, no, 24 and 1. They don't add up to be 19. Okay, so what does that mean? This is prime. No possible factors. Move on. 10x squared minus 63x plus 18. Let's see. Plus 18 means the signs are the same. Minus minus. Take your a, put it in front of both binomials. 10x minus something, 10x minus something. What two numbers multiply to be 10 times 18, and they're going to have to add up because the signs are the same to be a negative 63. That's odd. One odd, one even. Okay. Odd factors, 5 and a 2, 9 and 2. Whoop, 9 can be 3 and 3. Ooh, we have 3 odd factors here. Doggone it. Okay, so that means the 2 and the 2 have to be together because that's going to be my one even here. So I can't have a 2 over here with an odd. Okay, so let's see. We're going to have 3 times something, 5 times something, 9 times something, and since 63 is a big number, we're going to need a number that's small and big. So 60 and 3. Isolate 1, 3. 10 times 2 times 3 is 6. 60 and 3 add up to 63. When you have a big middle number and you're adding them together, your factors have to be far apart. So 3 times something, cover up the 3, 10 times 6, 60 and 3, add up to 63. Minus 3, minus 60, no GCF here. Stay that in the answer, take out the 10, x minus 6. There's my final answer. All right, to 5.4, we're going to talk about some special factoring techniques, factoring perfect square trinomials and difference of perfect squares. Notice that the first term, last term are perfect squares. Difference means there's subtraction. Squaring trinomials, that means it's a binomial squared. We talked about this earlier. Remember my smiley technique? That's this pattern right here. So since you're going to be seeing a lot of perfect square numbers, you should get used to 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. Notice that all these numbers squared. 7 squared is 49, 8 squared, 64, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared. You should have those memorized. They gotta look familiar to you. All right. It's also important, fill this in. Variable squared can be any variable to an even power. X squared, x to the 4th, x to the 6th, x to the 8th are considered perfect squares. Keep that in mind. So if I look at an example, let's go simple here. X squared minus 4x plus 4. That's a perfect square. That's a perfect square. I'm thinking my answer is a binomial squared. So I take the square root of the x squared, that's x. I take the square root of 4, that's a 2. I keep the sign of the middle term. I'm guessing it's x minus 2 squared. Now, I got to check for the minus 4 in the middle. X times, remember my smiley technique here? X times negative 2, double it. Negative 2x doubled, negative 4x. Yep, it checks. We're done. There's the smile part. X times negative 2 is negative 2x. You get another negative 2x or double it. Negative 4x. That's the way it factors. You're done. All right, let's try these. We have x squared plus 10, 25. Oh, perfect square with a plus sign in the middle. I'm guessing this is going to be x plus 5 binomial squared. Square root, keep the middle sign of the middle term. Now I got to do the middle term check. X times 5 is 5x, double it to 10x. Yep, it's a match. I'm done. X squared minus 8x plus 16, perfect square. X square root of 16, 4 with a minus sign. Middle term check, x times minus 4. Let's see, minus 4 doubled minus 8. Yep, there it is. Done. x squared plus 10x plus 9. How about an x plus 3? Wait a minute. 3x doubled to 6x. That's not 10x. That doesn't work. That means erase. Back to the old rule. X plus something, what two numbers multiply to be 9 and add up to be 10? 9 and 1, and now we're done. 4x squared, perfect square, minus 24x plus 36, perfect square. However, wait a minute. 4 can go into 24 and 36. You got to take out the GCF first. Even though those are perfect squares, they'll still be perfect squares right here. So now, perfect square, x3 minus. X minus 3 squared, leave the 4 out front. Middle term check. X times minus 3 is minus 3x doubled minus 6x. It checks. I'm done. 16x squared plus 24x plus 9, perfect square. I'm thinking 4x plus 3. Middle term check, 4x times 3 is 12x, doubled, 24x, I'm done. 9x squared minus 42x plus 49, perfect square. How about a 3x minus 7? Binomial squared. Middle term check. 3x times minus 7 is minus 21, doubles minus 42x. It checks out. It's done. All right, now, those difference of perfect squares. Remember when we FOILed this out, the middle term cancels. So it's a perfect square minus a perfect square. Only two terms. Be very careful. These difference of perfect squares can hide in other binomials, which means one of my binomial answers might be another difference of perfect squares. So here, if I wanted to factor completely, x squared, perfect square, 25, perfect square, minus sign, x plus 5, x minus 5. Take the square root of each one, 1 plus 1 minus, we're done. X squared minus 64, perfect square minus perfect square, x 8, x plus 8, x minus 8. 9x squared, perfect square, 36, perfect square. It's not 3x plus 6, 3x minus 6. 9 and 36 are divisible by 9. We have to take out the 9 first. You'll still get a difference of perfect squares. X plus 2, x minus 2. Keep the 9 out front. Okay? 16x to the fourth. Wait a minute. Yep, that's a perfect square because it's an even power. This is a perfect square. So when I take the square root of 16x to the fourth, that will be a 4x squared, and that will be a 9. So 4x squared plus 9, 4x squared minus 9. And we're not done. This last binomial, that's another difference of perfect square. This was hiding inside of this polynomial. 4x squared plus 9, I cannot factor. Leave that alone. But I'll have a 2x and a 3, 1 plus, 1 minus. Now it's factored completely. Circle, star this thing. Guarantee you'll see something like this on the test. Next we have x squared plus 4. We saw 4x squared plus 9 doesn't factor. X squared plus 4 doesn't factor. It's not a minus sign. It's prime. Wait a minute, 12 and 75, those aren't perfect squares. Oh, wait a minute, 12 and 75, they're divisible by 3. Let's take out a GCF of 3, we get 4x squared, 75 divided by 3 is 25. There's my difference of perfect squares. 2x plus 5, 2x minus 5. Don't forget to keep the 3 out in front. Okay, this is a trick question. One of two ways to do this problem. The negative's on the first term, not the second term. So you could take out a negative 1 and make it 36x squared minus 25y squared and say these are perfect squares. 6x plus 5y, once you take the square root of the 36 and the 25, and the x squared and the y squared, and 6x minus 5y. That's one possible way of doing it. The second way of doing this is say, hey, wait a minute. Why don't I just take the negative 36x squared, move it to the right of 25y squared, and that's my difference of perfect squares, and make it 5y plus 6x, 5y minus 6x, and that's the same answer as this right here. If I were to distribute the negative 1 into that second binomial, that gives me the 5y minus 6x, 5y plus 6x, and 6x plus 5y. They're the same. I think this is quicker. Holy cow, hundreds of perfect square, even power, perfect squares. We'll just divide the powers by 2. 121, yep, that's 11 squared. Even power, so I'm looking at 10 and 11. A squared, c to the third, x to the fourth, y to the first. So these are all perfect squares. So as I said, 10a squared c cubed plus 11x to the fourth y, then it's the same binomial with a minus sign. And that takes care of our perfect square trinomials and our difference of perfect squares. Again, mark that trick question right there. You will see that on the test. I'm really good at hiding those in there.